Hello React Native developers, what is going on? This episode is going to be a lot of fun, so welcome to Can It Be Done in React Native? This week we get some quality sleep. Hello guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. This week we are looking at the bedtime feature from iOS. So they have this really beautiful circular slider to select which time you want to go to bed and at which time you want to wake up. Speaking of delightful user experiences, I think this looks really nice and it feels very nice. You know, just to think that the alternative that you would see from other apps is going to be to have like two input selection. You tap on one, you have to scroll through the hours, scroll through the minutes, and you need to do this twice. Or you can have this beautiful circular slider. I think it's very exciting to look at. So you can select the date, and also if I go, you see I do one turn here, so it adds or remove 24 hours. So depending on how I slide the, up, or I slide the date and time. So I'm really excited about this example for three reasons. The first reason is that as soon as we see, without having any idea how to do this in React Native, we know because there is like some sort of circular effect, rotation, we know that this means trigonometry, and trigonometry means fun. So what do I mean by that is that when every time in this series we had to look at examples which are involving some sort of complex rotation, we had to use trigonometry, and we would like take our pen and paper and come up with an equation which looked very abstract, but while when we would translate it into React Native code, it would magically give us the expected result, which I think is really one of the great feelings you can get when doing programming. I think when doing programming, there's really a lot of things which feel great, and this is certainly one of them. So some sort of complex rotation means trigonometry, trigonometry means fun. And the second reason I'm very excited is that obviously it looks like we're gonna need SVG to build the circle and the animation, and we know, so again, this means React Native SVG working together with Reanimated, and these two modules work great together, plus gesture handler for the gesture. And this is a combination of modules that really work great together, and here we're going to reuse things we've learned from previous episode. I think it's very exciting. While researching the episode, I spent some time looking at some pull requests or GitHub issues, you know, related to animations, basically related to these modules working together. And I have to say that the work which has been done by each contributor from this module is just absolutely incredible. That they are enabling us to really build super smooth SVG animation on both iOS and Android declaratively. So it's just really, really exciting. And the last reason I'm very excited about this example is that, again, while researching it, it reminded me why I love React Native so much. I remember when I started React Native, one of the things which I really enjoyed is that we were using this really big innovation to do app development. And yet, because the technology was not so mature yet, there was still a lot of hacking going on. And, you know, if you were going on GitHub, people were really trying to figure out things out. Like no one knew, like we had to find, you know, we had to be clever about a lot of problems and just trying to figure things out and find clever, beautiful solution to ad hoc problems. And I really loved this mix of, I felt like I had the best of both worlds. So I had this really incredible innovation I could use in my professional life, and yet I could still have the pleasure of, you know, hacking things out. And certainly while researching this episode, because here again we're a bit on the edge of what can be done. Certainly we had to find like clever solutions to ad hoc problem. And so again, like this big innovation of like these declarative gestures and animations working perfectly together with the React Native SVG module. So great innovations. And also this, we need to be clever and, finding very elegant solutions to ad hoc problems. So how would we do this in React Native? Well, we clearly have some sort of SVG circle, and we know that, so we can have an arc which has any width. And in order to do this, it's a technique in web development in HTML, which is very commonly used. We can use stroke dash offset and stroke dash array. So we're going to use stroke dash array to set one dash of which is going to be the circumference of the circle, and the space between the two dash is going to be also the circumferences of the circle. So we know that basically by animating the offset value of the dash, we can have absolutely any size, any width for the arc. So we can really go from nothing to a full circle, and the next dash won't be appearing because the distance between two dash is the circumference of the circle. Pretty common technique that is used on the web, and here thanks to Reanimated and React Native SVG, we can use the same technique. Pretty straightforward. Of course, for any angle value, like let's say here I have 90 degrees. For the angle 90 degrees, we have, so for this arc width, we can of course have any start and end time. So we get the offset, but then also we need to rotate this circle. So for instance, from here to here, depending on which value is selected. So this part, pretty straightforward. Now let's get to the interesting part, the gesture, which will drive the animation. So we have these two buttons, and these two buttons are going to be assigned a pan gesture handler from React Native gesture handler. And then, so we grant the gesture. So now for any movement of the finger, I need to interpolate what is the position on the circle. I can move my finger anywhere on the screen, but of course, the cursor, the button, will always stay on the circle, right? And so we're going to do this to drive the animation. And so how do we interpolate the position of the cursor for any position of the finger? Let's write down our animations on paper. Here I have like a small sketch. So you see here, if I have a triangle, the top part of the triangle is actually my finger. So I can move my finger around to any position. Let's maybe take this position. So if my finger is positioned here, we know that the cursor should be positioned here at the intersection of the circle. So let me up. So we have our finger here, which is, we have X and so this value here is X, right? And this value is Y. And we know that this side here, so from the center to that intersects with the circle, is the radius, R. And if we know this angle, which is the same like for these two triangles, we can calculate this point, which will be, we can calculate X prime and y prime. So let me just write it down. So I have y prime here and x prime here. Oops, sorry. And using some simple, again, here we go on Wikipedia, trigonometry. These are the only, we have the scheme here. These are the only three formulas we need to know. And if we see tangent A is opposite divided by adjacent, which are actually here we have the y, here we have the x, right? So opposite divided by adjacent. So we know that, let me write it down. Oops. So we know that tangent of alpha is y divided by x, and therefore alpha is arctangent tan of y divided by x, because here x could be null and there is some other edge cases we need to handle. We can use another tool, which would be tan 2, first argument y, first argument x. tan 2 is essentially arctangent, handling all the edge cases. So if we were to use arctangent, we would need to check when x equals 0 and so on. And that's essentially what arctangent 2 does, with two arguments does for us. So we have alpha. So we know the angle, so that, just put it here. So now y prime and x prime are easy to compute. Again, if we go on Wikipedia, opposite sur hypoténuse. So we know that, sorry, I said it in French. So we know that y prime, so cosinus, sinus alpha is equal y prime divided by r. So hypotenuse is r. And cos alpha equals x prime divided by r. So let's write it down. Sinus alpha equals, again, so let me just check, opposite. So y prime divided by r, and cos alpha equals x prime divided by r, and so we have y prime, which is equal at sinus r times sinus alpha, sorry, and x prime equals r times cosinus alpha. So we know the position where so for any position of the finger, oh sorry, not this one. So the finger could be anywhere, and we know exactly where the button should be for any position of the finger. Pretty good, but here we used as coordinate system the center of the circle, right, which goes from 0 to r, 0 minus r, and so on. But we need to translate. We are getting the coordinates x and y from React Native, and not so based on the React Native coordinate system, not based on the center of the circle. So we're going to need to convert the x and y that is given from us by the gesture into the coordinate system of we just used here, and then so this is going to enable us to define the position with y prime and x prime in this coordinate system, which we need to set into translation React Native. So we're going to need to switch back and forth between the two coordinate system. How do we do the conversion between these two coordinate system? I don't know if there's maybe a mathematical tool to do it very easily, but I don't know it. So the way I did it is very simple. I just looked at the different values and see how they were translating to each other. So for instance, in the case of, let's start with x. So we have, if in React Native we have 0, then we get here, for x equals 0, we have minus r. For x equals r, we have 0. right? Because if here we are at R, we are in the center of the circle. Yes, that's correct. And then if we are at 2R, we get to R. So here it's easy to find out that x equals x prime minus R, because just by looking at this value, we see that, so it's 2R minus R, R equals R, R minus R equals 0, 0 minus R is equal minus R. So to go from x to x prime, so to go from x, so from x prime to x, we use this formula, and to go from x prime to x, so x prime equals Rx plus R. Pretty straightforward. Now let's do the same with, with y. So if y equals 0, so if y equals 0, we have R. If y equals R, we have 0. And then if y equals 2R, we have minus R. Think so, yeah. So this means that y equals minus y prime plus R. Let me try it. So if we have 0, we have R. If we have R, we have minus R plus R is equal to 0. If we have 2R, we have minus 2R plus R, which is equal at minus R. So that's correct. So, you know, maybe there is just I think there might be a more straightforward way to come up with the conversion from one coordinate system to the other. But I think this kind of just works. And so now we know that if we start from y prime, so we have minus y prime, let me just, minus y prime equals y minus R, and therefore y prime equals minus y plus R. Okay, so here we have everything we need. Yeah, so we know we get the x and y from React Native, from the gesture handler. We convert it into this coordinate system. We know which equation we need to apply in order to get the value. And finally, we need to switch back to the React Native coordinate system in order to apply the transformation. And so we can now drive the animation to the SVG. And I think that's pretty much it. But what do you guys think? Can it be done in React Native? Let's have a look. And 2 things before we get started. If you enjoy these videos, you can buy me a coffee to support the channel. I will give you access to the private GitHub repository where I tinker with all these examples. And if you have a new project coming up, you can check out React Native Elements. React Native Elements is a premium starter kit for iOS and Android. It is 80% of what you need when starting a new React Native project, from static analysis, latest libraries and best practices, as well as lots of beautiful UI components. So if you have a new project coming up, I recommend you check it out. All right, guys, let's get started. I think that we've done all the work we needed to do on paper, so the implementation now should be pretty straightforward. I created a project using Expo init, and then I have like my script, which I described in a previous video on how to convert this project into a TypeScript project. So simple container with a black background, a slider component, which is empty for now. This is where we're going to put our SVG circle, and another file, which is math.ts, which are some of the mathematical tools I need with Reanimated. And I was looking, so the version of Reanimated that I'm using with Expo 42 doesn't have a tan. So first I was looking at an implementation of React Native in Reanimated of a arctangent, which I found through Stack Overflow. So in a Stack Overflow question, I found the formula. I just needed to translate it into Reanimated. But then what you can do from there is to look at the Wikipedia article on arctangent 2, and then from there re-implement it yourself. But actually, while searching on Google, I found a really cool implementation of etan 2, which works really well. I ran some tests to see if it was giving me the right values. So obviously there is an approximation here, but with the degree of precision we need, this function is way more precise than we need it to be. So that's great. Also, what's interesting is I was like, okay, my version of Reanimating doesn't have arctangent. I also need arctangent 2. You feel, because it sounds like so specific to like, oh, Reanimated, Expo, and so on, but you think you're the only one to have such a problem. Actually, when you Google, you have like, people having the same problem for completely different use cases. And, there's just tons of resource online about these functions. So let's get started. We're going to draw our SVG circle. So I'm going to import SVG from Expo. And I'm going to need to set some size to the module. So I'm going to use the dimension module. So the size, I'm going to take the width actually of the screen. And maybe I'm going to use some, so the size is going to be width minus some padding, maybe 42, could be 64 pixels. Let's see how it looks like. Or yeah, 48 would be good as well also. So this is what we're going to use for the size. So this is the diameter of our circle. And we're going to set some width for the stroke of the circle. And so let's call it stroke width. Let's take 50. So we know, because the width, so the stroke is gonna fill 25 pixels outside, 25 pixels inside the circle. So we know that the radius is not size divided by 2, but rather size divided by 2 minus stroke width divided by 2. So radius equals size minus stroke width, yes, divided by 2. Up. Yeah, so here we have our container. In which we're gonna overlay, many things like the SVG circle and the cursors. So we're just gonna create the style. Oops. So width equals size, height equals size, and now we can put our SVG. Also width equals size. Here I'm not using absolute fill for the SVG element because it's not going to work on Android. So that's why I'm writing this twice, width and height. And we know that we have a circle inside, and it's going to be an animated circle because we're going to animate the stroke dash offset property. So animated circle. So we're going to use reanimated from the danger zone, danger. And so animated value, and we can create animated circle, which is animated dot create animated component of circle and circle we get from SVG. So the radius of the circle, we defined it, it's radius. C-ax is size divided by 2. Cy is size divided by 2. We have it at the center. Should it display, maybe if I do a fill red, should it display the circle? Yes, perfect. And we do have a stroke width here. And so maybe I can do a stroke fill red. Let's have a look. Oh, I think it's called stroke. Perfect. And here, if we go to the original app, I think it's like you see a gradient. All right, so for the gradient, I am very thankful to have a code snippet sent to me by Mr. React Native Gradient, Kathleen Miron. I recommend you check out his talk at appjs.conf. So I'm a lucky guy. I think I can just copy and paste this into my code. So I need to import, let me just defs linear gradient stop. So let's color pick the colors we need. That's one. That's two. Stop opacity we don't need. And here we can set 100%. And yeah, we can probably just use a function here. Just I'm gonna create a dummy variable so it doesn't remove the return expression, but yeah, that looks good. Let's have a look. And so it's named grad, so I can use URL grad. Let's have a look. Caitlin, thanks for the snippet. All right, so that looks good. So now, before we get to the cursors, let's try the dash stroke dash offset and stroke dash array animations. So first we need, because we know that the dash array is the circumference of the circle twice, so for the space and for the length of the dash. So circumference equals radius times pi times 2. So this is gonna be our dash stroke dash array. And stroke, I'm gonna put it here, sorry. Stroke dash offset is gonna be an animated value. So I can define it here. Okay, now if I add, I don't know, maybe pi, so 90 degrees, pi divided by 2. Sorry, pi divided by 2, so this is the angle, and so we need the length of the arc for this angle, so we simply do pi, so the angle times radius. This is gonna give us the length of. But do I have some, am I misspelling these attributes? That's probably what's going on. Let me check. Stroke dash array, that looks good. Stroke dash offset. Or is it, let me check, up, is maybe, because if I go back here, it's dash offset, there is no separation here. So that stroke dash offset, stroke dash array, let me check. Stroke dash array as well, okay. Up. Let's have a look. All right, perfect. So, but actually, we should do a subtraction of the circumference up, and I can use. Oh, so I don't have to use actually a value here, and I can import sub from okay, and so you see here for this angle, so for this time range could be anywhere in the clock. So we are going to need to apply some sort of rotation to the circle, depending on the values we're going to get from the gesture. So we'll do this after we're done with the gestures, but we know already that we can put, sorry, an animated view with a style. Oh, we're gonna have some rotate transform, so style sheet, absolute fill object, and transform of rotate z, which we're gonna leave to zero radiant for now. Okay, and maybe one last thing we can do before also is to have under our circle another circle which is gonna be static, where maybe, I don't know, RGB 50, 50, 50. Let's see how it looks like. Oh, stroke width. Something is wrong here. Okay, so here we have the fill of the top circle masking, so I can just add this one, fill none. Perfect. And maybe before we get to the cursor, there is one last thing we can do. Let me check. So I've downloaded this icon from the non-project. Here is the credit of the author. And so maybe we can use, let me see if we can use it in our code. I can remove this guy as well. Can remove this. Let's see if we can use this within the SVG. So I'm gonna use copy SVG code, and so play SVG up. Amazing tool. So because I can just paste my code. I want it for React Native, and boom, I can just copy and paste the expression. This is so cool. So let's see if we can integrate it easily in our code. Here I need to put it outside. I mean, for different reasons, different view box, and also I don't want the quadrant to rotate when I rotate this guy. So I am gonna put it here. So, sorry. Okay, actually, so width is not 88, so we're gonna set the view box to 88 view, because this one is based on a box of 88 pixels by 88 pixels. So we're gonna use view box 0, 0, 88, and here it's size. This guy we don't need. We do need to import path, and it's size mine. It's not size actually, but let's see. Let's import path. Text strings. What am I missing here? Okay. Perfect. But so we're gonna do a fill white, and maybe just like this. And so container, I'm gonna add justify content center align items center, and so size here I'm gonna remove the stroke width. Let's have a look. Times 2, sorry. Perfect. All right, so now let's get to the main event, building the gesture and animation. So I'm gonna create a cursor component. So we know actually there are gonna be 2 cursors, one for the start, one from the end. So let me just import it here. Okay, can create it here. And let me just create some variable here so that okay, so we have our component. So we have here some, so we're going to use gesture handler from expo, and we're going to use a pan gesture handler, and we're going to So from gesture handler, and we're going to use reanimated as well. This looks good, so we know that at the root we have pan gesture handler with it always needs to be wrap a single animated view. So we know we have this guy, and actually I can add some style. So width is 50, height 50, border radius 25, background color white. Okay, and actually pan gesture handler, let's go to the documentation, see how it should look like. So we have on gesture events, which we're going to define here. It's a React animated event, but we also need, and I always forget the syntax, but here we can just copy and paste it from here. Sorry. So import event. But there is also another property we need to use on. Is it on handler state change? Let me check. On handler state change, we assign the same event handler. This looks good. Now let's get this one. We don't need because we use reanimated. So now let's define the variables we need. So we are going to listen to this, correct? Yeah. Translation X, translation Y, state. So let's create these animation values. Translation Y. State undetermined, which we can import from here. So yes, very good. We need to have an absolute fill as well. Perfect. And we are gonna transform the view with translate X, translate X, translate Y, translate X, which we can quickly translate Y right now assigned to translation Y and translation X. So let's try quickly. So here you see I can move these buttons. Of course, now because I'm forgetting the one I'm gonna touch again, I'm forgetting where I was, so it's gonna snap back to position. If I do this, same. So now, first step, so there's two steps here. First step, we need to remember when we end the gesture where we've translated the cursor. And second step, we need to use the formula we computed before to constrain these cursors to only move within the bounds of the circle. So first, let's remember the offset of when we end the gesture. So I'm going to use a fragment here with an animated code. So I'm going to create two animation values, offset X, offset Y, where I'm going to store the value of where we were in the translation when ending the gesture. So let me create the values. Offset X equals new value offset Y, and I'm going to create also X and Y value, which are going to be actually right now is going to be the same than translate X but translate Y, but here these X and Y values are our input are going to be our input from the formula we computed, and then this is going to be the output. We're going to switch back and assign it to translate X and translate Y, but right now I'm just going to assign it to translate X, translate Y. So offset X, offset Y, X, X, perfect. So maybe I need to import block. I'm going to need condition and equal and add. So when the state of the gesture equals state end, and it's set as well, we assign offset X to X and offset Y to Y. And when the gesture is active, we can set X to offset X, which was the last, so the position in the last gesture, to translation X, which is the current position of the gesture, and same for Y. So here, if I reload, I should have the same result. Oops. But it's going to remember the position of, sorry about that. So let's have a look. All right. Oops. So it moved weirdly so it moves weirdly. You cannot see my finger, but I immediately saw, yeah, I have a mistake. Offset. So let's see. No. X, translate X is equal X, offset X. All right, sorry. I have a syntax error here. Okay. All right, perfect. So now you see it remembers which position I am. So last step, let's simply apply the formula we defined to this in order to constrain the cursor to be within the bound of the circle. So if we go back to the sketch file here. So we know the angle is arctangent 2 of yx, and then we just need to switch the coordinate. So let's do it. So I'm going to create an animation value called alpha. And we know that, oops, yeah, we can alpha equals arctangent 2 of yx, which I can import from the math module. But not y and x, but rather y and x prime, which we know prime, x prime, y prime, which we know are these formulas here. So for y, we need to multiply it by -1 and subtract the radius. And for x, we need to subtract the radius. Just import these functions. We need to pass the radius as property here. And now we don't assign translate x and translate y to x and y, but rather to, oops, these two values we calculated here. So we set translate x to multiply radius times cos alpha. And same for y, so with sinus alpha, right? But these are not x and y, are not translate x and translate y, that rather translate x prime, translate y prime. So we need to go back to this coordinate system. And so again, here, so for x, I'm gonna add radius. And same for, so -1 times radius. I probably have some up. I need to import sinus and yeah, I did remove the two animation values, but still need to declare them. Looks good. And multiply, add, and add radius. Let's have a look. Okay, this one is a tan2, not arctan2. And so, up, multiply that. So now you see it moves perfectly within the bounds of the circle. So now we have our alpha value, which we can use here in the slider in order to display the arc as it should be. So I'm going to create two variables, one for the starting cursor, one for the end cursor, which will contain the angle value. So let's create start and end. So here I'm going to pass it as a property to each cursor. So this one is going to be the start, this one is going to be the end. Okay, so here I have angle, which is a type of value. And so I can assign here angle to alpha. So now we can animate the stroke-offset. So we need essentially the delta of the of the two angles. So I'm going to create delta equals end minus start. So this is our this is the angle we want to do, and so we know that the arc, the length of the arc is multiply delta by radius. Just need to import this guy here. Let's have a look. So all right, that looks good in the sense that you see the arc, the length of the arc seems to be always correct, but now we just need to rotate accordingly. So I'm gonna subtract pi, so 2 pi, 1 rotation to the start angle. Let's have a look. So that looks good, but you see here this flip, and it's because, I mean, it's not big. So here, okay, what happens is that here so let's take this moving cursor. So here you see it's at pi divided by 2, and here it's getting close to pi, almost pi, and here I'm getting to minus pi. So therefore he thinks that the end angle is smaller than start. And so this you could fix by normalizing the angle to be always positive. But then if you do this, when here I go to a full revolution, sorry, so here I'm like close to 2 pi, here I'm suddenly close to 0. So now he thinks that ends is also smaller than start. So it's also going to flick at this position. And what happens in the Apple app is that it does not flick. And then once these two cross, one rotation has been done. So what we're going to do is if end is less than start, we're going to add a full rotation, so 2 pi. So if less than end is less than start, we add 2 pi to the end angle, If not, everything is good. So this should give us the same result than from the Apple app. Let's try. So here, and I'm gonna go 1 full revolution. Perfect. Cool, huh? Isn't it? Very cool. So I think we're done here. Pretty cool example. Was a lot of fun to do the math and then applying basically just what we wrote down into Reanimated and have it working very well with SVG. Guys, I hope you enjoyed this video. Thank you so much for watching. I'm looking forward to talk to you soon. And in the meantime, happy hacking.